we'll move to the second part of 12th question. If the final mixture of gases is passed through a U-tube containing sodium hydroxide, what is the final volume of gas in cm cube? Again, sodium hydroxide is a strong alkali. Here carbon dioxide is acidic, therefore carbon dioxide should be trapped in sodium hydroxide. So you should expect only oxygen to escape here. But here again they haven't given the quantity of sodium hydroxide. You shouldn't bother about that. This is the style of the MCQs. So you shouldn't think of those. Here you should assume that the total amount of CO2 is trapped here. Some oxygen may be trapped as well. You shouldn't bother about that also. Then according to the art of the paper, you should have the sense that only oxygen escapes when the gaseous mixture is bubbled through sodium hydroxide. Then according to our calculation earlier, 0.066 7, that much of oxygen was left after the complete reaction. Then that into 24 should be the volume of oxygen. Then 24 into 0.0667, that is 1.6 dm cube. 1.6 dm cube. Then they are asking it in cm cube, then 1600 cm cube. Then the answer should be B. Then 12B, the correct answer is capital B. Second choice is the correct answer. 13th one. A halogenoalkane is dissolved in aqueous ethanol. You see, halogenoalkane is dissolved in aqueous ethanol. When aqueous silanitrate is added, a white precipitate forms immediately. See the bold letter here. Immediately a white precipitate forms. Then if you have gone through the relevant theory, you should know that there should be a tertiary halogenoalkane, because it should undergo an SN1 reaction mechanism here. Then the first one is a primary halogenoalkane, second one 2-chlorobutane secondary, 1-chloro-2-methyl again as primary, 2-chloro-2-methyl tertiary. So the correct answer is D. Last one is the correct answer. 13th one, last one is the correct answer. We'll discuss the theory here. Methylpropane. Here this is a tertiary carbon. Then if CCl bond is broken heterolytically before reaching the OH minus ion, a tertiary carbocation is formed. This tertiary carbocation is stabilized due to both the inductive effect and hyperconjugation. Therefore it is highly stable. thereafter the OH minus should nucleophilically reach the carbocation. So since the tertiary carbocation is highly stable with compared to primary and secondary carbocations, here primary carbocation is the least stable, secondary one and tertiary one. Tertiary one is the most stable here due to the inductive effect and the hyperconjugation. Then only the fourth choice out of the given 4 choices, only fourth choice shows a tertiary alkyl halide 2-chloro-2-methyl propane. Therefore it should be the correct answer for the 13th question. Then question number 14. Propanol and propanone are isomers, that's true. Which mass over charge peak would not be expected in the mass spectrum of propanone ketone? Then 15, you know that both of them have a CH3 group. Then there are 3 CH3 groups here. Then 15 is possible. 29, the aldehyde can remove CH3 CH2 plus, that is at 29. No, CHO plus, both are 29 depending on the stability, either C2H5 plus or CHO plus would be formed, which is responsible for 29. But in the ketone there shouldn't be a peak at 29. There is no stable peak, stable chemical species which is responsible for 29. Then 43 here CH3CO should be here carbon 12 12 24 27 43. So CH3CO would be 43. Here also CH2CHO, both of them can show 43, peak at 43. We'll write one equation for that. Anyway, the answer here they are asking which MOIZ peak would not be expected in the mass spectrum of propanone. Then for the propanone B is the answer. For the 14th one B should be the answer. We'll write the equations here. For 29, CH3 CH2 CHO, here molar mass is 58. Then once it is bombarded with fast moving electrons, we'll say that C2H5 free radical plus CHO plus or C2H5 plus and CHO radical will be formed. It depends on the stability. Anyway, both are 29. So 29 peak will be shown by the propanol, but propanone cannot show a peak at 29 because there is no any stable chemical species which can be formed by the electron bombardment. 58 is the molecular ion peak, that is common for both. So 29 will be shown only by the relevant aldehyde propanol. So the answer is B, 14AB. Then 14B, propanol and propanone can be distinguished by chemical tests. Which pair of observations is correct? You should know that propanol can undergo further oxidation, but propanone resist further oxidation. Here warm with failing solution. Here aldehyde can undergo oxidation, thereby copper 2 plus present in failing solution can undergo reduction. Therefore there should be an observation here, but they say no change. Then first one is wrong. Second one, add solid PCl5. Here PCl5 there is no OH group here, therefore there is no reaction in both the cases, but here it says mist fumes in the right side. That's wrong. Warm with acidified potassium dichromate. This oxidizing agent oxidizes easily the propanol. Then it turns potassium dichromate green. That's true. But ketone normally does not undergo oxidation. It resists further oxidation. Then there is no change for that. Therefore C is correct. Then D, add sodium hydrogen carbonate. It says fissures. Then we have to expect an acidic hydrogen. They are not acidic. Both aldehyde, propanol and propanone are not acidic enough. They don't have hydrogen atoms acidic enough to react with hydrogen carbonate to give carbon dioxide. Therefore there is no reaction in either case. Here the last one is also wrong. Here potassium dichromate undergoes reduction from +6 to +3. Then green color can be seen in the acidic medium. So that is correct. Then there is no change for the relevant ketone. Therefore the correct answer is C. Okay, then I want to emphasize you should understand the art of answering for MCQs. For the structured questions you have to face in a different way, but for the MCQs you have to play just like 2020 cricket match. Here if you are talented enough to guess the answer, you can quickly take the answer. So you can complete the paper within a short time period. Then you have enough time to check the answers again and again. Again we'll go through the questions fast. First one, enthalpy change of formation. Then definitely you should target on 1 mole of the chemical species. Then you should cancel the second choice B. Then out of A, C and D, here you should take the physical states correctly. Here iodine should be a solid, but in the other A and C, iodine is in the gas form. That is wrong. Then D should be the answer. Second one, here they say 50 cm cubes are used from HCl and sodium hydroxide with the same concentration. Then the temperature rise is 13. Then instead of 50 they have used 25 cm cube in the second event while maintaining the other one at 50 cm cube. Then this is a neutralization reaction. Actually the reaction between HCl and sodium hydroxide means the reaction between hydroxonium OH plus ions and OH minus in the neutralization to form water. Therefore it depends on the heat energy given out. The quantity of the heat energy given out depends on the amount of water formed. Therefore when the volume of the HCl is half of the initial one, then amount of water formed becomes half of the initial amount of water. Therefore instead of 13, now it should be 6.5 degrees Celsius is the temperature rise, provided that 100 cm cube is the, that means the same volume should be there, but instead of 100 only 25 plus 50, that is 75 cm cube is there. Volume has decreased. When the volume decreases, temperature rise should increase with the same proportion. So we expect it to have 6.5, because instead of 13 now it should be 6.5, provided that the same volume is there, but volume has decreased. Then temperature rise should be little greater than 6.5, that is that into 100 over 75. Third one, in an MCQ you shouldn't draw and practice energy level diagrams in the exam hall. You have to do it at home. Therefore you better just understand with compared to the total energy required to break the bonds of the reactants, the total energy given out when NH bonds are formed or ammonia molecules are formed is 92. Additionally, 92 kilojoule energy has been given out. Therefore, you just add up the energy required to break NN bond, that is 945, then 3 HH bonds, then 436 into 3, that's the total energy required to break the bonds of the reactants. Then plus additionally they have ammonia. When ammonia is formed, additionally 92 kilojoule energy has been given out. Then at that 92 also, even though it is minus, negative means heat energy has been given out. You shouldn't bother about this negative charge. Then 945 plus 436 into 3 plus 92 is the total energy given out when those atoms, N atoms and H atoms reorganize to form 2 moles of ammonia. Then total energy divided by 6 is the strength of 1 NH bond. Here fourth one, how many moles of CO2 are formed when 3 moles of chloroethene is mixed with 10 moles of oxygen? Then you simply understand, see that they have already printed the balance equation. It's then very convenient for you to take the answer quickly. Here 2:5 is the ratio, that means 1:2.5. Then 3 moles of chloroethene should react with 7.5 moles of oxygen. But available quantity is 10 moles, that is in excess. Therefore limiting factor is chloroethene. That governs the end of the reaction. So 1 mole of chloroethene should form 2 moles of CO2. Then if 3 moles of chloroethene is there, then 6 moles of CO2 should be formed. Fifth one, then here you decreasing boiling temperature. Now here, just like in reading scanning and skimming, here you have to just like skimming, you have to just go through the choices here, the given compounds here, whether to find whether ionic compounds or giant covalent lattices are there. All are, just by looking at that, you should have the sense to take the understand that there are no ionic compounds here, no giant covalent lattices, simple molecular structures are there. Then you just go through the choices here. Here from left to, in the first one, left to right, the number of C atoms increases. Then boiling point should increase along that, because all are non-polar hydrocarbons. Second one, here hexane, 2-methylpentane, 2,2-dimethylbutane. Then all are isomers. But from left to right, it's getting more and more branched. Then boiling point should decrease. So that's the answer, then decrease in boiling temperature. Third one, C, part C, the third choice, alcohol here, propan 1-ol, propan 1,2-diol, propan 1,2,3 triol. Number of OH groups increases, then number of hydrogen bonds increases. That's the key factor. Don't bother about the London dispersion forces here and PD attractions. Here more and more hydrogen bonds are there, then overall strength of the intermolecular attraction forces should increase from left to right. Last one, chlorobromo and iodomethane, then all are almost non-polar. Then London dispersion forces should increase from left to right, because chlorine 17 electrons, bromine 35 electrons, iodine 53 electrons. Then when the number of electrons increases per molecule, strength of the London dispersion forces increases from left to right, boiling point should increase. Thereby you have to find the correct answer. Here chlorine is a sixth question. Chlorine is added to 2 cm cube of dilute solution of potassium hydroxide. The equation has been given here. Which statement is correct? Iodide ions oxidize. Now you be careful whether to see whether it's active voice or passive voice. Here iodide ions oxidize chlorine. Iodide ions oxidize chlorine is wrong. It's killing basic principles. Chlorine is more electronegative than that. Based on that also you can understand, you should have the sense that it is wrong. Anyway, iodide ions oxidize chlorine is wrong. Chlorine undergoes a reduction here. Second one, iodide ions reduce chlorine. Yes, it goes from 0 to -1. Chlorine is more greedy for electrons, therefore chlorine grabs the electrons from iodide ions. Therefore iodide ions reduce. Iodide ions kneel down in the presence of chlorine. Iodide ions loses electrons. Then iodide ions reduce chlorine. Yes, that is correct. Then chlorine, once you take the correct answer, then you have to go to the next question if you are confident of the answer. We'll go through the other two also. Chlorine reduces iodide ions, that is also killing basic principles. Iodide I minus is the low, -1 is the lowest possible oxidation state of iodine, being group 7 element, 7 or 17. Then neither it's a redox reaction. Then fourth one is also incorrect. Then part B, when the reaction is complete, 10 cm cube of cyclohexane is added. They have given the density. If you don't know the density, if you don't have any idea about the density, then you better go through that. Anyway, this cyclohexane is less dense than water or this aqueous solution. The mixture is shaken and left to settle into 2 layers, which description of one of these layers is correct. Then within the syllabus you should know that the cyclohexane layer or the organic layer, non-polar layer, turns purple or any shade of purple when iodine molecules migrate into that layer. So you have to bring these marks from your home. You shouldn't waste time in the exam hall to think or analyze those. You just understand that it should be purple. Then the first one is correct. The upper layer means cyclohexane layer is purple. Lower layer is purple, that's wrong. If you have done practicals, you should know that iodine should be brown in color, but majority of iodine I2 has migrated into the cyclohexane layer because non-polar cyclohexane will welcome the non-polar I2 molecule solute. So lower layer purple, wrong. The upper layer brown, wrong. Triiodide ions will not migrate into that layer. The lower layer is brown. If the concentration of triiodide is high, it will be brown in color, but majority of I2 should have already migrated into that cyclohexane layer. Therefore now it shouldn't be brown. The brown color should move towards very pale yellow brown color. Therefore the answer is C. Seventh one, going from calcium to barium in group 2, which property changes as stated? Ionic radius, that is even an O-level student can understand that it is wrong, because down the group number of shells increases. Second one, first ionization energy decreases, that's true, because large shell is getting far away from the nucleus. Third one, melting point increases, it should decrease because atomic size or the cationic size increases down the group in the giant metallic lattice. Reactivity with water decreases? No, it increases, because its reactivity means it tends to lose the outermost 2 electrons to achieve a stable electronic configuration. Therefore, down the group it should increase the rate. 8th question. Properties of group 2 compounds change down the group from magnesium to which statement is correct? Solubility of group 2 if you have undergone the respective theory, the recommended textbook and all properly at home, just by looking at that you should understand that barium sulfate is soluble and barium sulfate is insoluble, magnesium sulfate is soluble. That means down the group solubility of sulfates decreases, then increasing is wrong. Then solubility of group 2 hydroxides, then only barium hydroxide is soluble to a certain extent, significant extent in group 2. Most of the other hydroxides are less soluble. Magnesium hydroxide, we can say that it is insoluble or very much less soluble. Calcium hydroxide is somewhat soluble. Strontium and barium, like that, down the group solubility somewhat increases. Then solubility of group 2 hydroxide increases, then decreasing is wrong. Thermal stability of group 2 nitrates, earlier I explained that one thing is the cationic size increases down the group, charge density decreases, polarizing power decreases down the group, thereby it weakens the bonds in the anion to a lesser extent, thereby down the group thermal stability increases. Then third one correct, fourth one incorrect. Other than that, you have to compare the sizes of the respective carbonate and oxide. We'll take example magnesium carbonate to magnesium oxide and carbon dioxide. We'll compare it with barium carbonate and barium oxide. Here carbonate is relatively a bigger large anion here out of the ions involved here. Then magnesium carbonate to barium carbonate, intionic distance and magnesium oxide to barium oxide intionic distance should be compared. Here with compared to carbonate, oxide is very much smaller. Then you have to regard that it is very small. Therefore that oxide, when the oxide ion is smaller, magnesium 2 plus to barium 2 plus, increase in cationic size becomes a significant percentage increase between cation and anion from magnesium oxide to barium oxide. When the inter-ionic distance increases significantly, the heat energy given out becomes significantly low. That means when magnesium carbonate absorbs heat energy to undergo dissociation, a certain significant fraction of the heat energy borrowed is compensated, given back when strong lattice is formed here, magnesium oxide. Therefore, it is less endothermic. The thermal decomposition of magnesium carbonate is less endothermic, whereas thermal decomposition of barium carbonate is more endothermic. Therefore, more and more heat energy should be supplied down the group. Then down the group, thermal stability increases. 9th one, here balance equation has they have given the equation with coefficients here. You should know that the iodine undergoes a disproportionation reaction. Here iodine goes from 0 to -1 in sodium iodide, 0 to +5 in sodium iodide 5. Then 0 to -1 it gains 1, 0 to +5 it loses 5. Therefore, in order to balance the equation, there should be 5 sodium iodide along with 1 sodium iodide 5 form. So 5:1 is the ratio. Then last one should be the answer. So 9th one D. 10th one, ecosodium iodide reacts with ecosilver nitrate to form precipitated silver iodide, which is correct for silver iodide. Then silver, you should know that silver chloride white, silver bromide cream, silver iodide yellow. Then it should be yellow in color. Then only first two choices are correct. Then solubility in concentrated ammonia. Silver chloride is soluble in dill ammonia. Silver bromide is soluble only in conc ammonia. Silver iodide does not dissolve even in conc ammonia. So it is insoluble. So the correct choice is A. Second one, what is the percentage atom economy by mass of the product of silver iodide in this reaction? Then that is the desired product. Then you just come, since they have given the relative masses of them, quickly you can take the final answer. Here desired product shows 234.8, whereas byproduct shows just 85. So desired product shows a higher fraction of the total mass. Therefore, definitely atom economy should be significantly greater than 50%. So out of the 4 choices, only D shows a significantly greater value than 50. So the answer is 73. So you should be confident to take that answer by kicking away the other answers. If you are not confident, then you better use a cal and take the final answer. Then you are not given additional marks for that additional botheration. 11th one, ethanol can be prepared by reacting chloroethane with aqueous potassium hydroxide. What type of reaction occurs here? Then nucleophilic substitution reaction is there. Then substitution is the correct answer. Then how do the boiling temperatures of ethanol and chloroethane compare, and what is the reason for the difference? Chloroethane shows stronger dispersion forces, but that is overcome by stronger hydrogen bonds in ethanol. Therefore, ethanol has a higher boiling point. So out of the 4 choices, A and B are the answers. Then reasoning is here it shows hydrogen, only ethanol forms hydrogen bonds. Then bromoethane and chloroethane react with aqueous potassium hydroxide at different rates, which is correct. Then that's kinetic factor. Then difference in rate here with compared to chloroethane, bromoethane, here BR-C bond is longer, easy to be broken. Then bromoethane reacts fast. Then first 2 choices are correct. Then explanation. Then not the polarity. Explanation comes under the strength of the bond. CBr bond is weaker than CCl bond. That's the answer. Then capital B, second choice is the correct choice. Again, butanol burns completely in oxygen. 7.4 grams of butanol burn completely in 16 dm cube of oxygen, and mixture of gases produced was cooled to RTP. At room temperature and pressure, what is a liquid? So carbon dioxide is a gas. If oxygen is in excess, some oxygen will be left. What is the final volume of the mixture of gases in dm cube? Then if your left hemisphere of the brain has developed more, quickly you can take the answer. Here 74 means 1 mole, 7.4 means 0.1 mole. Then 0.1 mole of ROH is there. Then oxygen, 16 dm cube of oxygen. 24 dm cube is 1 mole. Then 16 means 2 eighths. Here 24 means 3 eighths. So 2/3 oxygen. So according to the balance equation, it's 1:6 ratio. Then 0.1, that is 1/10, should react with 6/10 moles of oxygen. But the available quantity is 6/9. Your maths knowledge should be sufficient to understand that 6/9 is greater than 6/10. So available quantity is greater. Then 6/9 minus 6/10 is the remaining oxygen after the reaction. So 1/10, 0.1 mole of alcohol should produce 0.4 moles of CO2 according to the balance equation given. So if it is 0.4 into 24 into 4 means 96, then 9.6 moles of dm cube of CO2 should be there. But little oxygen is there, therefore total volume should be little greater than 9.6. Then the answer should be B. Or else you should do the calculation and find the answer. If the final mixture of gases is passed through U tube containing sodium hydroxide, what's the final volume of gas in cm cube? Then sodium hydroxide, you should assume that all the CO2 is absorbed by sodium hydroxide. Then what is left is only oxygen as the gas. So the remaining gas is 6/9 minus 6/10. Then that into 24 is the volume in dm cube, that into 1000 is the volume in cm cube. Next one, halogenoalkanes. Halogenoalkane is dissolved in aqueous ethanol. When aqueous selenitrate is added, a white precipitate forms immediately. Then if a white, this that haloalkane, may not dissolve in water, that's why they have used some ethanol, aqueous ethanol. Then aqueous selenitrate has been added. Then the selenitrate ionizes into Sila plus and nitrate. With the aid of water, this will CCl bond will be heterolytically cleavage to form the carbocation. Then immediately silva-iodide will be formed, provided that the resultant carbocation is highly stabilized. So if it is a tertiary one, then due to the positive inductive effect and the conjugation here, it will be stabilized. Then tertiary carbocation, hyperconjugation and the positive inductive effect will stabilize the tertiary carbocation to the greatest extent. Then you should have the sense of finding the tertiary carbocation just by looking at that. Here 1 chloro means here primary, 2 chloro means here secondary, 1 chloro 2 methyl, here 1 chloro, that is a terminal chlorine, then it is primary, 2 chloro 2 methyl, then it is tertiary, it should be tertiary. So the answer is D. Then propanol and propanone isomers would not be expected in the mass spectrum. Here you according to your scope, you should not struggle to find whether CHO plus O, C2H5 plus is more stable. Anyway, use simple mathematics. You may break it into parts at the correct places, then when you remove CH3, CH3 plus, if it is positively charged, there should be a peak at 15. Here also there should be a peak at 15. Then if CH3 is removed as a free radical while the rest is a positive ion, then 58 minus 15 equals 43. Then 43 is possible for both, but 29 will be shown by the aldehyde, because C2H, once C2H5 at this place it is broken. When C2H5 COH, when it is broken at that place, when an electron bombards that, there will be a peak at 29. Then either C2H5 plus or COH plus will be responsible for the peak at 29. But propanone ketone doesn't show a peak at 29. There is no stable chemical species that can be formed. Then 58 is the molecular ion peak, that is shown by both. Then 14b, propanol and propanone can be distinguished by chemical tests. Then you should understand that normally propanone, the ketone, does not undergo further oxidation. If you do a research at the research level, you will understand that it can undergo further oxidation if acidified potassium permanganate, like strong oxidizing agent is added. But for the moment you should accept that ketones do not undergo or resist further oxidation. Normally, in general, ketones resist further oxidation, but aldehyde can undergo further oxidation to carboxylic acid or carboxylate ion if the medium is alkaline. Here failing solution is alkaline, therefore aldehyde propanol will be oxidized to not to the propanoic acid, propanoate. So it's an oxidation. Then copper 2 plus, alkaline copper 2 plus ion should undergo reduction. Then brick red precipitate should be there. Here they say no change, then it is wrong. Then propanone side, it should be no change, but they have, then both the sides are wrong. Second one, PCl5, then there is no OH here in both the cases, therefore no mixed fumes of HCl here in both the cases. Warm with acidified potassium dichromate, it will oxidize the aldehyde propanol to the propanoic acid here. Then dichromate turns to Cr3 plus. Then it turns green, since both anion from the acid and water surround the Cr3 plus side. So normally it turns green. Then it turns green, that is true. Then other one, no change, because ketone resists further oxidation. Last one, sodium hydrogen carbonate, fissure, it says fissures, then it should be the hydrogen carbonate should be protonated, followed by it should undergo decomposition to form water and CO2. But there is no acidic hydrogen. The hydrogen atoms in both propanol and propanone are not acidic enough to react with hydrogen carbonate, therefore that is also wrong. Then when you do the MCQs, you think of the art that you have to bet here. Here in most of the cases you can guess the correct answer within a very short time period. Then you can complete the paper within a short time period, then you have sufficient time to go through the paper again and again until you feel confident of the answer to gain 100%. Okay, then we have to move to the structured questions.